Warning, this video is technical. Only watch it if you are a bit geeky.
Hello. So, what do I have here? Well, some time ago I've done a video about adding a digital audio output connector, SPDIF output connector, to a Sony PCM digital decoder. There were three models commonly used that you could add one of these to. The PCM-F1, which was associated with a portable. I've got one of those. PCM-501ES and a 701ES. And there was a 601ES that had a version of this kind of built in, but isn't actually quite as good as this one, in my opinion. Now, I have only had one of these boards, and I put it in the end. It had started out life in my 701, and I took it out of the 701 because I was having trouble with it. I fitted it to the 501, still had trouble with it, and then I fixed it. I had to add a capacitor. And it stayed in the 501 because that's got an extra feature. It's got an OVP control on the 501 decoder, which the 701 doesn't. Even though some people say the 701's a better decoder because it has better DACs and ADCs, it's not relevant if you're bypassing all that and going for digital output. So I have a 701 which has had one of these installed before but doesn't have one now because I didn't have a spare. So let's install this in the 701 and test it over temperature, because I don't know if you saw my video before about all the trouble I've had with these, but I had found that one was quite temperature sensitive. So let's test it thoroughly. This is a very subtly different version than the one I've had before. It's a very slightly different PCB, I think, but it's got the same pin out, the same connectors, and does the same job. So let's install that into the 701, where a very similar board had been before, and test it thoroughly. So here's the PCM-701ES decoder. This machine I actually bought years ago on eBay, and it didn't work when I first got it, and the reason was that it had a fault. There was a resistor that had gone slightly high value. It was a fusible resistor, but it had gone high value for no other reason than it just felt like it. There wasn't an overload condition, and it was still sort of working, but high value, as a result of which was mains hum on everything. This is where the decoder had been installed before. So all the wires go to the relevant places on the board for the various signals that this requires. I'll get you a better view of that. Right, so this, what I originally fitted it back in 2018, has got a multitude of wires going to the underside of this PCB. And I see also I have added a wire here. This is one which will connect to the LED on the board, which indicates that it's in a locked status. And I'd fitted a small LED on the bottom of the machine, I think. Yes, it's still there. So we'll add that feature again. And the output goes to this special socket at the back here. It's a phono socket, but it needs to be insulated from the metal panel. So it's a particular type of phono socket there. And I have some coaxial cable which is going to this bracket, which was where I'd mounted the board. So that needs to go to the output of this there. So I'll desolder the socket there I've used. And this wasn't very good because that wasn't a properly insulated socket, so I don't know how they'd mounted that, but clearly that was no good. Very important to make sure that I get the multi-way connector the right way round, so I will be checking that against the documentation. Not quite sure where pin 1 is. No, well, we need to be very careful. My cable here is keywayed, so it should be correct, but of course this was for a different version of the board. So I'm not taking anything for granted. I'll make sure that pin 1 is right way around on this. Looking at the diagram, I see that pins 1, 3 and 5 are all ground, and looking at the circuit board, that must be then 1, 2, 3, 4, 5, 1, 3 and 5 all ground, as is pin 9. So that's pin 1 there. Up there. How odd. Which makes this completely back to front for my cable. Because I'm fairly sure that red connection there is pin 1. I'd better check that, hadn't I? Can't take any risks with this. Had they made up the cable differently? Yes, look. There, pin 1 is the red wire, but with my plug fitted the same way round, that would give me the wrong end. That's a bit of a calamity. How am I going to solve that? Let's see if I've got ground on 1, 3 and 5, and then on pin 9. Should be there. Yes. So this is built the other way round. These boards are not interchangeable. That's a nuisance. So I need to rebuild this connector that way round, or swap this over. If I swap that over, then that will make my two boards interchangeable. That might be the safest thing to do. Right, I'm going to have a go at that. I'm going to see if I can desolder that connector and swap it round. That's correct. Okay, that's all installed and looks like it's working. But last time I worked with one of these, I had a lot of trouble with the phase lock loop chip. It was temperature sensitive until I modified the board slightly. So I need to hook this all up with a player, a beta player, providing the proper input signal to this, and then a digital output from this into a digital audio recorder, and then we can test it more thoroughly. Right, let me show you exactly how I wire that up here. Okay, the first thing I'm going to need is a suitable beta player. Now, any beta player could be used, but I've chosen the C9 and the other model is the F1, which are particularly well suited to this because they have a switch in the back marked PCM, and I'm going to switch that to the PCM position. That disables the internal dropout compensator, and actually I plan on adding such a switch to another machine. I've got a Sanyo NTSC deck that I want to add that kind of switch facility to, and that could be another YouTube video in itself. So how are we going to connect all this up? Well, we need the video out from this to go to the video in on this decoder. Let's start with that. We need a BNC to phono cable for that, because I've used phono sockets for the video signals on the decoder, even though they have BNC sockets on the video recorder. You do wonder why the lack of consistency. So that will go to video in. Now the next connection, of course, of interest is this SPDIF output, which we need to connect to a digital audio recorder. Now normally in my studio I use a big Tascam SSR250N for most of my recordings, but this little handheld one is handy for the workshop here because it has a digital input, albeit you have to go through some whole menus to get there. So now I need phono to phono, twin phono to phono, so I'll just use the same channel on both sides. Should use a decent quality cable for that, because of course there's a fairly high frequency signal. If I connect a pair of headphones to the digital audio recorder, all I need to do now is power it all up and put a tape in and give it a whirl. Go through the various menus on here. Okay, the beta machine is running. Let's put the tape in. We'll also power up the decoder. And the first thing, of course, will be to check that the system works in its normal analog state. Aha. Took a moment, but now we have VU meters there. So the most important thing here is to switch this over to the tracking feature, and you aim to peak this, and it should be up here as high as you can get it. So we'll try the tracking and see if we can make that even higher. It seems to be giving me the best results when it's roughly in the middle of the tracking, which is always a good sign. I think I'll put the monitor on so we can view it on the monitor. So there's an output on the back of this labelled monitor, and that's the pattern that we're quite familiar with now. I think anybody who's ever done any of this will be used to that. But of course, if we go way off the proper tracking, you'll see that it all gets disturbed. Okay, we're happy with that. I'll just rewind the tape a little while I set up the digital audio recorder. Go into the menu, and this really could be a lot easier to use. Remote Digi In. You get function and switch it from being one of the remote control inputs to Digi In. Now I also want to set the recording format to be 44.1 kilohertz sample rate 16-bit, which is the same as the recording on this tape. I'm having trouble with this little wheel here. It's starting to get a bit worn and it's making it very hard to use. Okay, that was set for 24 bits, so we need to fix that. Press play. And that seems to be working. And we could indeed make the recording. Now, for content match reasons, I can't let you hear the music. But I will check now that it doesn't sound distorted. It sounds excellent, but too bright. And there's a good reason for that, because this emphasis flag is set, so there is an emphasis, pre-emphasis on the recording, and what we need to do when we get the file from this is apply a curve to do the de-emphasis, and I've covered that on another video. But now what we need to do is heat and cool that phase lock loop chip and confirm that it remains fully working. If it goes wrong, you'll see this little Tascam recorder say something like DIN unlock. Right, how I'm going to heat and cool that IC, map it into the rescue. Now if I make the chip really cold, perhaps losing phase lock isn't that unlikely, but it should take a little cooling. That's looking good. Still working. Let's cool the rest of this circuit as well. Perfect. A bit of heat. My hot air is set to about 100. It's just broken up and died. Did you see that? Got didn't unlock. Huh. Let's come back now. Did I just go too far there? 100 is a minimum temperature I can do on the hot air system. It didn't go into done unlock, but it did start to crackle. Try a little bit more. Not too much. Yes, it does seem to break up when the IC gets warm. And it's gone into done unlock mode again. And it's staying there. So we could have jitter on that phase lock loop just like we did on the last one. Let's try cooling the phase lock loop tube again. And now try it. Now it's working. So we have a problem. Okay, well it's better to find out now than when I'm trying to use it. So let's investigate further. Okay, last time we had this problem with temperature sensitive phase lock loop chip, I had a problem that the signal would jitter when the IC warmed up. So let's warm up the IC and see if that's still true. So at the moment that's a nice stable signal. Let's warm it up a little. Right, hot air gun on the phase lock loop chip, trying not to knock my probe off. Let's try to demonstrate the problem. We have the digital input coming in here, and with clean sharp signals on here because the IC is cool, everything is working perfectly. But if I warm up the IC with the hot air gun here, so I'm going to warm up the phase lock loop chip. I can hear distortion. It's gone into DIN unlock. And we can see huge amounts of timing jitter from the output from the phase lock loop. And I can't capture the audio now. If I squirt some freezer on the phase lock loop chip, these edges sharpen up, and now I can capture the audio cleanly again. Right, last time we had that problem I was able to solve it by the addition of two very small value capacitors to either side of a capacitor that's already on the board. So let's do that again. I think it was a 12 picofarad and a 100 picofarad, something like that I added. Let's do the same again and see if it stabilizes it. This is the phase lock loop chip. This is pin 8 here, which is ground. From pin 7 to 8 I've added 18 picofarads, and from pin 6 to 8 I've added 100 picofarads. That I found worked perfectly last time I had one of these boards. So let's see if that stabilized the phase lock loop over temperature. Well, what are we seeing? I think we're seeing intermittent going all over the place even at this temperature, so I suspect that's made things worse in this case. Yes, it's made things worse. How strange. If I call the phase lock loop, what happens? They stabilise. It's good now. So those capacitors improved stability on the last board I had of this design and made it worse on this board. This isn't going to be easy to fix, is it? A quick sanity check with both capacitors removed. Seems to be fairly stable again, at least until it warms up. Okay, let's add just the 100 picofarad capacitor. Okay, we have just the 100 picofarad capacitor. That seems to be stable. Okay. And I have audio on there. Let's heat it up. It's going all unstable again. So those capacitors are not helping on this board in the way that they did on a previous one. Oh dear. What can I do? I could add more decoupling across the supply rails for the IC, I suppose, but there's already some decoupling on there, so I'm not sure that's going to do a lot. Okay, I've added some supply decoupling. I'd be surprised if it makes any difference, but it certainly shouldn't make anything any worse. Okay, let's run a tape. And heat up the phase lock loop. I think I'm seeing jitter. I can hear distortion. However, it's not as bad as it was. Well, it's pretty bad. No, it's gone. Right. Decoupling didn't help. Didn't think it would. Well, I'm doing this in a not particularly scientific way. I've got it heated up so it's jittering like crazy, and I've got my 100 picofarad capacitor, and I'm sticking it between ground and various pins on the IC. And look what seems to happen when I put it onto pin 2. Stability. Take it off, unstable. Put it on, stable. Let's heat it up a bit and confirm that's true. Get it really, really jittery. Right, that is all over the place. Very jittery, and now put it on that capacitor on pin 2. It's solid. Capacitor off. We like that. Let's try soldering a 100 picofarad capacitor between pin 2 and ground. Okay, let's give that a whirl. So we have the 100 picofarad capacitor in place. Let's see if we can capture the audio. Okay, looking good so far. We have a quiet patch on the tape, I suspect. We may be having some trouble with the beta video player. Okay, we have audio. Right. I don't know why I had a little glitch there, but get over that. No, that's distorted. That's not stable at all. So it may visually look okay there, but we're not winning in terms of satisfactory phase lock loop performance, no. Another fail. Okay, remove that capacitor. Yes, better without it. Okay, I've put an 18 picofarad capacitor between pin 2 and ground. Let's see if that gets us anywhere. That looks stable. Sounds good. Let's warm it up. It's quite hot now. Okay, I eventually got it to go into din unlock, but yes, it's gone now, but it was fairly hot before that happened. So it's not fixed, but I suspect it's just a tiny bit better. But you can see it's sort of hanging on and then going really, really bad. Now it's down to reasonable temperature. I suspect that might be as good as I can get. It's certainly better than it was. It takes quite a lot of heat now to get it to lose that phase lock loop lock. What I'll probably do is reassemble it and then just let it get up to its own normal operating temperature and see if it's reliable. I've added a piece of metal. I've glued this onto the top of the phase lock loop chip. It's kind of a heatsink temperature stabilizing device. I wish I had a proper heatsink like the one I fitted to the other decoder, but this has been sat here now for some hours and it's barely above ambient. So I will do another test later with the lid on as well to try to catch the temperature when it's warmed up. But it seems to be 100% stable now. I'm quite pleased with that. I can't get it to skip a beat at all. Right, having stabilised the PCM decoder, let's sort out the SL-C9 that keeps stopping in rewind and fast forward. A lovely feature about this machine is that it has two reel motors, just one for each spool, and that cuts out reel idlers and all that rubbish. This is what you get on professional decks like Betacam. Nice feature. This and the F1 both have this. Also some V2000 machines from Philips have the same. Okay. So what could be the problem? Well, I suspect it may be one of these Hall effect sensors, and they're a right pain to get hold of. One of them has a tiny solder splash, potentially just about touching the two contacts. Well, there was some suspect soldering there. Let's see what happens if we give it a whirl now. Check first that play works. That's fine. Okay, fast forward. No. You know what? I don't think it is the sensors, because this tape remaining thing can only work by measuring the speed of the spools. And if that works out, yes it has, it's worked out where it is. So it can't be failing to detect the spool rotation. There's some other reason it's shutting down and fast forward and rewind. Have a look on the Palsite website, it's very good. Lots of great information about these machines. And it suggested looking at capacitors, and it particularly suggested this one, 033 on the board for this fault. Actually that one looks fine, but next door, I think it's number 17, that looks terrible. Open circuit, says my test meter. It's supposed to be 10 microfarads. That one's okay, so it just seems to be number 17, it's completely gone. I'll check some others as well in this general area, but certainly number 17 is well cooked. In cutting it off, I don't risk reforming it by heating it up. 10 microfarad 16 volt. And I'm reading about 4 microfarads. Well, I only found the one capacitor out of spec, and even that still had a little bit of capacitance left in it. And when you consider that this machine is, 40 years old pretty much, that's pretty impressive that only one capacitor is bad. But let's see if it works now. That does actually seem to have fixed it. Oh good, let's put it back together and test it some more. Okay, let's do a final test on that. First a bit of rewind and fast forward. Yeah, that's looking good. Oh, machine brought down by that little capacitor. Fast forward. Let's try play. That's all fine. So that was a nice little extra bonus to the PCM digital audio video. How to fix your Sony C9. Good, that's a result. Fast forward and rewind now seem to be stable in the C9. I actually had one more problem, which I didn't record, which was that eject would sometimes jam, and it was just the loading eject belt, which was an easy replacement. Now, next video, what could this be? Something I'll be testing. Hopefully that works fine. So please do remember to like, share and especially subscribe, and I'll do a lot more content on audio and video technology in the near future. Bye for now.